Now let's look at how we can use the definition of the logarithm, the inverse properties of logarithmic and exponential functions, and the one-to-one properties of log and exponential functions to help us solve simple exponential and simple logarithmic equations. Okay, so notice again, I highlighted the properties of inverses last video, but this time highlighting the properties of one-to-one functions. So if you have like bases that are equal, then the exponents have to be equal. Likewise, the logarithmic function is the inverse of the exponential function and therefore is also a one-to-one function. So if the log base a of one quantity equals log base a of another quantity, the only way that can happen is if the two quantities are equal. Okay, and also I'd like to mention some special bases. Base e, which is the number we looked at when we did some compound interest applications and continuous compound interest. It's approximately 2.71828. And then the number 10, which we typically do base 10 arithmetic. But if the base of a logarithm is e, we tend to shorthand that as looks like an L and N of x, and we call that the natural logarithm. So again, that's base e. And if the base is 10, we shorthand log of x, and we call that a common logarithm. Typically on calculators, as you can see from the screenshot, you have those two buttons are built into your calculator as convenient bases to access with the logarithms. Okay, so to solve the equations we have in front of us, the first one is 10 to the power x equals the number 575. And my first thought is it would be great if 575 were a power of 10, but since it isn't, we can use our definition of a logarithm and rewrite this guy in logarithmic form. So the exponent x will be log base 10 of 575, which you can type it in the way I've written it here, or you can shorthand log base 10 as log 575. The question stipulates that you give a symbolic answer and not a decimal answer, so we can type either one of those in as our solution. Okay. And part 2, the equation is x to the power negative x over 8 is the value 64 over 101. And personally, I don't want to try to guess what power of e would produce 64 over 101. So let's use our definition, which is the exponent is log base e of 64 divided by 101. And continuing to solve for x, we would multiply both sides by negative 8. And you can leave it like this, or you can use the shorthand natural log notation and write x equals negative 8 natural log of 64 divided by 101. And again, yes, those parentheses are very important, especially in WebAssign. Okay.